Okay, so the topic for this video is going to be 30, 60, 90 triangles, the second of our special right triangles. And our essential question is going to be, what are the properties of these 30, 60, 90 triangles, and how are they used to solve problems? There are two types of right triangles that are particularly common in mathematics and tend to appear frequently. These are known as special right triangles, the second of which is the 30, 60, 90 triangle. So what is this thing? It's quite simply just a right triangle with a 30-degree angle and a 60-degree angle. So these often look like this, where we've got our 30-degree angle and our 60-degree angle. Nothing too radical here. They just have those three angle measures. All right. Now, to get into the different properties of them, let's look down here where it says, use the Pythagorean theorem to determine the length of the altitude of the following equilateral triangles. So all three of these things are equilateral triangles that have had the altitude drawn in. All right, so let's go ahead and figure out what the altitude is. That is the x that we're going to try to solve for here. So if you remember back from when we were investigating different properties of triangles and whatnot, you might remember that the altitude of an isosceles or an equilateral triangle also bisects the base, right? So if I'm looking at this little triangle right here, if one side of the equilateral triangle is 4, that's going to mean that all the sides are 4, which ends up meaning that AD here is 2. So that's going to be what allows us to set up our Pythagorean theorem. So if I do a squared plus b squared equals c squared here, I'm doing 2 squared plus x squared equals 4 squared. 2 squared is 4. 4 squared is 16. Subtract the 4, I get 12. Square root of 12 could be simplified down to 4 and 3. 4 gives me a pair of 2's. So that means that this is going to be 2 square root 3. Now, just to make sure that we kind of understand what's going on here, this little triangle that we just worked with, this is a 30, 60, 90 triangle, right? That top angle is also getting bisected by that altitude, since it's an equilateral triangle. So that's a little 30, 60, 90 triangle. Let's run this one more time, but now with a side length of 6. So if that's 6, this is 6. This whole thing here is 6, which means that this bottom piece will be 3 if it gets cut in half. Okay. So now this one, a squared plus b squared equals c squared. This is going to be 3 squared plus x squared equals 6 squared. That's 9 plus x squared equals 36. If I subtract the 36, I'm going to get 27. That could be 9 and 3, which gives me a pair of 3's. So this will be 3 root 3. And last one here. If all the sides of our equilateral triangle are 8, that means AD there is 4. So get our legs, get our hypotenuse for our 30, 60, 90 triangle. And let's do 4 squared plus x squared equals 8 squared. 16 plus x squared equals 64. That will give me, what's that, 48? 48 could be 16 and 3, which gives me a pair of 4's. So this is 4 root 3. Now, in all of those cases, those 30, 60, 90 triangles are similar triangles, right? And similar triangles, they're just different sizes of each other, but the same proportions, same ratios. So we can imagine that this pattern is going to continue no matter what kind of side lengths we have. So you probably noticed there 2 root 3 and 4, right? 3 root 3 and 6, 4 root 3 and 8. These patterns are going to exist for every 30, 60, 90 triangle because they are all similar versions, right? They're all going to have those same types of ratios attached to them. So let's formalize these little patterns that we just discovered by doing that. So let's kind of illustrate our 30, 60, 90 triangle here. What we have is a short leg that is opposite the 30. We have a long leg that is opposite the 60. And then we obviously have the hypotenuse, which is opposite the 90, okay? Now, if the short leg is x, let's just go ahead and call the short leg x. Could be anything. Could be 2, 3, 7, 100, could be anything. If the short leg is x, then to get the long leg, you are going to do x times root 3. So that would be short times root 3, right? Whatever the short leg is, and our version there was x, you take that, you multiply by root 3. So it could be 5 times root 3. It could be 10 times root 3. It could be root 2 times root 3 if the short leg's root 2, right? Could be anything, whatever the short leg is, times root 3. To find the hypotenuse, you are going to do 2 times x. 2 times the short leg. Okay? So if the short leg is 5, the hypotenuse is 10, right? That's what we saw up here. 2 times 2 is 4. 2 times 3 was 6. 2 times 4 was 8, right? The short leg is half of it because it's half of the length of the equilateral triangle. Now, those ones are easy to do if you know what the short leg is. But maybe you don't know what the short leg is. If you don't know what the short leg is, then you can do two things. You could take the long leg and divide by root 3, or you could do the hypotenuse and divide by 2. Okay? So those are all the different things you could do to find the short leg. You can do the long leg divided by root 3, or you could do the hypotenuse divided by 2. So definitely a little bit more going on here than we had with the 45, 90s. But those are going to be the general patterns that we're going to need to follow. Okay, so let's try a few out. The more we do, the more comfortable we're going to get. So example 2 here on the inside of your little book says solve for x and y. Okay, let's go ahead and start with x, I suppose. X is the hypotenuse, right? And we know the short leg. That side that we have, the 4, that's the short leg. How do I know that? Because that's opposite the 30, right? The 30 would be up here, so that's my short leg. Y is going to be my long leg because it's opposite the 60, and x is the hypotenuse because that's opposite the 90. So let's find x. X is the hypotenuse. So what did we do to find the hypotenuse? We said the hypotenuse was equal to 2 times the short leg. So that should be x is equal to 2 times 4. X is 8. Okay, now to find the long leg, we said that the long leg was equal to the short leg times root 3. 4 times root 3, they don't mix, they just get stuck together. 4 root 3. That one is a nice little basic one there. Everything. Okay, let's identify our short long and hypotenuse here. That should be my short leg because that's opposite where the 30 goes. This is my long leg because it's opposite the 60. 10 is my hypotenuse. Okay, so in this case, X is the long leg. We don't have a way of relating the long leg to the hypotenuse. So instead, let's go find Y first. Y is the short leg. And we know that the short leg should be equal to the hypotenuse divided by 2. So Y should be 5. Now, once I know what the short leg is, I can find the long leg because the long leg should be equal to the short leg times root 3. So 5 times root 3 is 5 root 3. And there we go. So that one we had to kind of go backwards first by finding the short leg. And then once I know the short leg, I can find whatever I need. All right, what's this one got for me? So on this one, there's my 30. So Y is my short leg, 6 root 3 is my long leg, and X is my hypotenuse. So for this one, to find X first, I can't really do it because I don't have the short leg. So let's find the short leg first. If you don't know the short leg, you should always find the short leg first. Y is the short leg, and we know that to find the short leg from the long leg, we're supposed to do the long leg divided by root 3. So 6 root 3 divided by root 3, I can divide those radicals out of there, and I get 6 for the short leg. And then once I know what the short leg is, I can do 2 times the short leg to find the hypotenuse. 2 times 6 is 12. So that's a 6 root 3, 12. All right, now on this one, once again, we know what the long leg is first. The short leg is that X. The long leg is the 6. That's where the 60 would go. And my hypotenuse is the Y. So to find the short leg, because we always want to find the short leg first if we don't know it, we are supposed to do the long leg divided by root 3. Now, this should make you think about what we had to do a few times on the last video for the 45/45/90s, where we have to rationalize the denominator because we don't like having that root 3 on the bottom. And instead of doing it with root 2 like we did with the 45/45/90s, we got to do it with root 3 this time. Now, if I multiply straight across, 6 times root 3 is 6 root 3. If I multiply the denominators, root 3 times root 3 is root 9. But root 9, the square root of 9 is 3. And now I've got some whole numbers on the numerator and the denominator. And if I've got whole numbers, I can actually divide those things. So 6 divided by 3 is 2 root 3. So X ends up being 2 root 3. And that's the short leg, which means that when I go to find the hypotenuse, I was supposed to do 2 times the short leg. So 2 times 2 root 3, because the short leg's 2 root 3. Well, I can multiply those numbers that are outside of the radical. 2 times 2 is 4 root 3. And there we go. So that one was a little bit trickier than the other ones, but we're still following the same rules, right? We started off by doing long leg divided by root 3 to get the short leg. And then we just did 2 times the short leg to get the hypotenuse. Alrighty, so what do we have for example 6? This says solve for X and the perimeter of the equilateral triangle. Okay, well, if this is an equilateral triangle, remember we got ourselves a little 30, 60, 90 triangle right here, right? That's my short leg. The altitude, there's my long leg. And this would be my hypotenuse. So we know the long leg. Let me just go ahead and put a Y right there for now, just to kind of help write out my work. y should be 5 root 3 divided by root 3. Because 5 root 3 is the long leg, and I want to know the short leg. So I do the long leg divided by root 3. Root 3 divided by root 3 would be 5. So this is 5. And if that's 5, then the hypotenuse, x, should be 2 times the short leg, 2 times 5. So x should be 10. And if that's 10, that means every side of my equilateral triangle is 10. So the perimeter should be 10 plus 10 plus 10. So the perimeter should be 30. No problemo. All right, let's keep it cruising here. For example 7, says solve for x and y. Okay, we know the short leg. The long leg is the x, because that's opposite where the 60 is. And the hypotenuse is the y. Okay, so to find the long leg first, I guess. Let's just go ahead and say that the long leg should be the short leg times root 3. Now, root 3 times root 3, we can multiply those radicals. That should be 4 root 9. But what is the square root of 9? The square root of 9 is 3. And 4 times 3 is 12. Now for the hypotenuse is supposed to be 2 times the short leg. So 2 times 4 root 3. And 2 times 4 is 8 root 3. Okay, what do we have for number 8 here? That'd be my 30 up top. So x is my short leg, 15 is my long leg, and y is my hypotenuse. So to find the short leg, always want to find the short leg first if we can. Let's go ahead and do the long leg divided by root 3. Don't like the root 3 on the bottom. So 15 times root 3 is 15 root 3. Root 3 times root 3 is root 9. Root 9 is 3. So x should be 5 root 3 when I divide that 15 by 3. Then to find the hypotenuse, we're going to take 2 times the short leg, 2 times 5 root 3. That should be 10 root 3. Okay, just root 15. That's interesting. A little bit of a weird one here for the last one. We've got a short leg of x, got a long leg of y, and a hypotenuse of 20 root 15. Okay, always want to find the short leg first if we can. So let's go ahead and do x, that's the short leg, is equal to the hypotenuse divided by 2. Remember, the hypotenuse divided by 2 is also equal to the short leg. Now, we don't need to do any sort of rationalizing because it's not a radical on the bottom. We've got some whole numbers on the numerator and the denominator. So 20 divided by 2, that's 10 root 15. So x should be 10 root 15. We can't simplify root 15. We could break it down into a 3 and a 5, but we're not going to get any perfect squares out of that thing. So leave it as 10 root 15. That is simplified. Then to find the long leg, we are supposed to take the short leg and multiply by root 3. So root 15 times root 3. Root 15 times root 3 is root 45. Now, 45 we can simplify. That could be a 9 and a 5, and 9's a perfect square. So I do get a pair of 3s. So what ends up happening here, we already have a 10 on the outside. Now we get to bring a 3 to the outside, and we still have a 5 left over. So 10 times 3 is 30 root 5. That would be the fully simplified version of y. So 10 root 15, 30 root 5, and 20 root 15. Some pretty crazy radicals in there. All right, hopefully you're catching on to the pattern there, and remember, just keep referring back to these rules here. This is what you got to know. So your turn to shine. Go ahead and try those your turn problems. Bunch of basic ones at the front there, and then we slowly get a little trickier. Give those a shot, and then come back and check when you're ready to see how you did. All right, so for number 1, we should have gotten that x was 9 root 3 and y was 18. That one was about as straightforward as they get. For the next one, to get x, you should have done 12 divided by 2. So you get 6. And then y should have been, once x was 6, y was just 6 root 3. For this one, should have gotten y first. You should have done 10 root 3 divided by root 3 to get y to be 10. And then x should have been 2 times 10 to be 20. For number 4, this is where it started to get a little bit weird. To get x, you should have done 21 divided by root 3. Done the root 3 over root 3 thing. We get 21 root 3 over root 9. But what's root 9? Root 9 is 3. 21 divided by 3 is 7 root 3 for x. And then if that's 7 root 3, we do 10 times 7 root 3, and we get that y is 14 root 3. For number 5, 8 root 12 for the short leg. Okay. Well, to go from the short leg to the long leg, like to find y, we're supposed to do 8 root 12 times root 3. Now, root 12 times root 3 is root 36. And 36 is a perfect square. That's 6. So 8 times 6 is 48. So y should have been 48. X, on the other hand, we do 2 times 8 root 12. And we get 16 root 12. Now, some of you guys might have left it like that, and I get it, but honestly, root 12 can be simplified. That's a pair of 2's. So we get to bring a 2 out. We already had a 16. So 16 times 2 and a root 3. That should be 32 root 3. That'd be the simplified version for x. If you left it at 16 root 12, that one was tricky. I get it. Determine the perimeter of the equilateral triangle. Okay, so we did one like this in the notes. We got our long leg right there, short leg there, hypotenuse here. So let me just call this x and this y for now. If I want to find x, the short leg, I should have done 6 divided by root 3. That is 6 root 3 over root 9, but root 9 is 3, and that is 2 root 3 for x. Now, if that's 2 root 3, then y is 2 times 2 root 3. That's really sloppy. Let me write that again. 2 times 2 root 3, which is 4 root 3. Which means that all the sides are 4 root 3. So the perimeter should be 4 root 3 plus 4 root 3 plus 4 root 3, which is 12 root 3. That should have been the perimeter there. All right, hopefully those went well for y'all, and that is going to conclude our video.